Another way that we can talk about translations is by using coordinate notation. Coordinate notation starts with a set of coordinates. We're on page 66, by the way, at the very bottom. Starts with a set of coordinates, your pre-image coordinates. And then the coordinate notation tells you how much to add or subtract to those coordinates. So this literally says you take the X number and you add 4. Then you take the Y number and you add 6. And let's see how that plays out down here. We started with -2, and we're supposed to be adding 4. So -2 plus 4, +2. -3, we're supposed to be adding 4. -3 plus 4, +1. -1 plus 4 gives us +3. The Y's should follow the rule as well. 1 plus 6 is 7. -2 plus 6 is 4. -2 plus 6 is again 4. So for some folks, this might be a preferred way that you can write translations if you're ever asked to write them. For everyone, you certainly need to be able to recognize what's going on here. You can use coordinate notation to represent any of the kinds of transformations that we're going to be doing. For translations, you're going to be limited to adding and subtracting from these X's and Y's. If it doesn't add and it doesn't subtract, then it's not representing a translation, it is some other kind of transformation. So let's use this vector, -2, 3, and let's make our own coordinate notation rule that we apply to the point over here in this graph, or the points in this chart. So if the vector says to move left 2 or down, left 2, this is going to be X minus 2. They conveniently had the minus in there for us. If you ever run into something where it had a plus right there, you could just put X plus -2. The Y's say to increase by 3, so this is going to be Y plus 3. And now we can start filling in our chart. I personally like to do all the X's and then all the Y's, rather than switching back and forth between -2 plus 3, -2 plus 3, -2 plus 3. So I'm just going to go do all of my X's, and I'm going to subtract 2 from every one of them. So 3 minus 2 is 1, 2 minus 2 is 0, 4 minus 2 is 2. Then separately I go do my Y's. 0 plus 3 is 3, -2 plus 3 is 1, -2 plus 3 is again 1. If the pre-image had these coordinates, this one it says is A, this one it says is B, and this one it says is C, our changed versions are going to be A prime, B prime, C prime. And all of the side lengths, all of the angles, which direction is up, all of those things are going to be the same from the pre-image to our image if we have calculated these points and graphed them correctly. So let's kind of review all of the different ways that we have talked about translations. We're going to be on page 69, just using some examples here. We talked about pre-image and image. The pre-image is the original. The image is the changed version after some kind of transformation has been done. One type of translation, which just slides our figure over a certain amount, slides it up and down and left and right, whichever directions. One type of translation is a vector. A vector can be drawn as an arrow, like this. So this vector might be GH. We talked about the symbol. We could also put another little letter under there. Let's make it like F. This could also be vector F. The component form of that vector looks like this. The first number tells the change in X, the second number tells the change in Y. So for GF, our change in X is 1, 2, 3, 4, 5. So we would put a positive 5 for our change in x. We also would have a change in y. Our change in y would be down 2. So our change in y is a negative 2, and that is the component form of vector GH, also called vector F. The last thing we talked about was how we could also write this in coordinate notation. So coordinate notation would look something more like this. It says start with any x and any y. And if we want to write this vector in coordinate notation, it would look like x plus 6, comma, y minus 11. It still represents the change in x and the change in y, just like our component form did, but a little more specifically. You don't have as much guesswork because it literally says take the x and add 6, take the y and add 11. But they all represent translations, which once again slide a figure up or down and left or right.